Welcome to XFO Intelligence Podcast. I'm your host, and today we're diving deep into a groundbreaking framework that's reshaping how we understand intelligence itself. What if I told you that the most profound insights about intelligence don't come from studying brilliant minds or powerful computers, but from observing a brainless yellow blob solving mazes? Today, we're exploring emergent intelligence, a revolutionary concept that reveals how complex, intelligent behavior arises spontaneously from simple components working together. This methodology forms a key part of the Deep Augmented Thinking framework, invented by Brendon Wong from XFO Intelligence. By the end of this episode, you'll understand why a slime mold, a student's mind map, and the world's most advanced AI all operate under the same fundamental laws of intelligence. Let's begin with something that challenges everything we think we know about problem solving. In 2010, Japanese researchers conducted an experiment that would forever change our understanding of intelligence. They placed a single-celled organism called Physarum polycephalum, a slime mold with no brain, no nervous system, in a maze with food at the exits. What happened next was extraordinary. This brainless blob extended tendrils through the corridors, explored dead ends, retracted from failures, and ultimately found and reinforced the single most efficient path connecting all food sources. It solved the maze not through conscious thought, but through emergent intelligence. This leads us to the first of three fundamental laws that govern all intelligent systems: the law of local rules. Intelligent global behavior doesn't require an intelligent global controller. Instead, it arises from many simple components following simple, local rules. Each part of the slime mold only responded to its immediate chemical environment with a basic rule: flow toward food. Yet collectively, this created sophisticated problem-solving behavior. The second example takes us from biology to human cognition. Picture a student struggling with a complex essay. She draws a central concept on paper and begins radiating lines outward, connecting ideas, facts, and questions in the mind map. Meaning emerges from the web of lines between concepts, mirroring how our brains create associations. Our third example brings us to artificial intelligence. In a data center, a large language model receives a prompt. Across billions of artificial neurons, trillions of simple mathematical operations fire in a decentralized dance. No single neuron understands language, yet from this coordinated chaos, coherent, insightful responses emerge. This illustrates our third law, the law of feedback. Intelligent systems continuously optimize through reinforcement and pruning. They explore possibilities, strengthen successful paths, and eliminate failures. The AI reinforces neural pathways that lead to correct predictions while weakening those that don't. These three laws, local rules, network architecture, and feedback loops, form the foundation of emergent intelligence. But understanding these laws is one thing. Harnessing them is where Brendon Wong's Deep Augmented Thinking framework becomes revolutionary. Deep Augmented Thinking, or DAT, is a disciplined methodology that consciously applies these three laws to human-AI collaboration. It's built on three pillars that mirror the laws of emergence. First, slow thinking, setting the local rules. This prioritizes deliberate, analytical thought over fast, biased intuition, preventing the system from rushing to suboptimal solutions. Second, augmented intelligence, building the network. AI tools extend human cognitive architecture, creating intelligence not in the human or AI alone, but in the quality of connections between them. Third, ethical systems design, implementing feedback loops. This establishes principles that reinforce positive outcomes while pruning harmful or unethical paths. The DAT method creates a compounding cycle of intelligence building through 6 steps: mind mapping thoughts, collecting information via AI, building knowledge bases, creating specialized chatbots, recording insights, and repeating the cycle. Each iteration enriches the network, leading to increasingly sophisticated emergent insights. This framework is intensely practical. It provides blueprints for revolutionizing computing through transparent. We're not just building artificial intelligence, we're discovering and instantiating universal laws of intelligence in new mediums. This changes our role from engineers building rigid machines to gardeners of intelligent systems. Our task is to design conditions for emergence, set simple rules, provide feedback nutrients, and define network boundaries. We tend the garden while humbly acknowledging that the most beautiful patterns, the true aha moments, emerge from collaboration in ways we cannot always predict. The story of emergent intelligence is ultimately about discovering a deeper order underlying our world. It's a testament to the power of simplicity, connectivity, and feedback. By learning to speak this common language of emergence through frameworks like Deep Augmented Thinking, we gain the power not just to build smarter machines, but to cultivate a smarter, more adaptive, and more resilient future. If you're fascinated by these concepts and want to dive deeper into the Deep Augmented Thinking methodology, I encourage you to request a copy of the comprehensive white paper on Deep Augmented Thinking, recently released by XFO Intelligence. This detailed framework guide will show you exactly how to implement these principles in your own work and thinking processes. Thank you for joining us on XFO Intelligence Podcast. Until next time, keep thinking deeply. And remember, intelligence isn't just designed, it's grown.